Hello everyone, welcome to this session on Linux interview questions. Linux is probably the most used operating system in today's world. Any production system that you talk about, 80 or 90% chances are there that they will be using the Linux operating system. So today in this session, we have basically collated some of the most asked Linux interview questions that you can come across while you're sitting in your next interview. So let's get started. Now we have divided these interview questions into three sections, that is beginner, intermediate and then expert. And we have basically collated 10 questions each in all of these sections. But before we move on guys, if you haven't already, please subscribe to the Intellipaat channel and click on that bell icon to never miss out on any updates from us. Right? So let's go ahead and get started with the first section, which is the beginner section.
Let's start off with the first question, which is the most simplest question of all, comparing Linux with Windows. So we're comparing it in three criteria. So the type of OS. Linux is open source, anybody could use it, you can download it and you can even make changes to the kernel's code, but you cannot do that in Windows because Windows is the proprietary operating system. You can buy it and install it and you'll have to activate it by giving money. So you'll have to give money to Microsoft for the activated version of Windows. In Linux, it's completely open source. Customization. Linux can be customized, as I told you. You can change the code however you want. You can make the changes to the kernel all by yourself. You can get the code online. So that's why it's open source and really popular. And also in Windows, it cannot be changed because it's completely owned by Microsoft. Security is amazing in Linux, but in Windows you'll have to have a good antivirus software. Even if you have a good antivirus software, there will be some kind of a malware which slips into your system and that might cause damage. But in Linux, security is amazing. There is not many chances of viruses getting into Linux so there is no chance of viruses getting into Linux. But in Windows, there is a lot of security issues existing already. And if you use Windows Defender or if you use any security tool, any antivirus tool, again, there might be some security issues if you do not follow certain steps. So the thing you'll have to understand is, as an operating system, Linux is better than Windows. Windows is better in the GUI part than Linux, but Linux is more to the customization side. If you're a developer or if you're working with computers a lot, then Linux is the go-to operating system. Next question is, what is LILO? So now LILO is short for Linux Loader. While you load into your system, if it is just a Windows system, then it gets directly logged into the Windows system. If it is a Linux system, it directly gets logged into the Linux system. But if you have a boot menu where you have dual booted your system with Linux as well as Windows, in that case, what will happen is you'll get a LILO boot menu. So Linux Loader boot menu, where you'll have to choose on what operating system should be booted right now. So Linux Loader is a bootloader for Linux. It is used to load Linux into memory and start the operating system. LILO can be configured to boot other operating systems as well. So you can configure it to boot Linux, Windows, or any other type of Linux operating system you need. LILO is also a code snippet that loads PC BIOS into the main memory at the time of starting the computer system. So basically, when you switch on your computer, a code basically runs in the background to start off the operating system. So that's why at the beginning it shows some loading icons, then it shows you some menus, and then it goes into the operating system, because before opening or loading the operating system, there is a step before, which is basically the code snippet which runs to start off your operating system. So basically the Linux Loader handles these tasks. It locates the kernel of Linux, so that once it locates the kernel of Linux, only then you can basically enter the operating system. Then it identifies other supporting programs and loading them in memory. So basically, once the Linux kernel is on, you'll also have the other Linux programs and utilities. So all those applications and memory should be loaded. Once that is loaded, the kernel will start and you can log in into your operating system and start using it. So this is Linux Loader. Coming to the third question. Suppose you wish to print a file draft with 60 lines on a page. What command do you use? So basically, the command for this purpose is PR-L60 draft. So now, the default page length when using PR is 66 lines. You'll have to use the L command to basically reduce the length to 60. So there is a file called draft, and you want to print the first 60 lines on the page, and you go to the command pr, and if you want to like reduce the number of lines, you'll have to use the l command, that's -l, and put the number of lines because the default number is 66. The fourth question, what is ld_library_path? What is ld library path? It is an environment variable used for debugging a new library or a non-standard library. So basically a library which you install into your Linux system. It can be a new one or it can be a non-standard library which was created by some other user. It is also used to identify the directories that need to be searched for. In order to do this, the path to search for the directories needs to be specified. The variable can be set using the following command, that is setnv -ld library path $path. So this is basically used to search for the shared objects or dynamic libraries by the operating system for extendable functionality at the runtime. So basically this particular command chooses the library's path, and with this path you can basically run that library whenever you want it to run. So that's what they are mentioning in the last sentence. It is used to search for shared objects or dynamic libraries, so the library which you installed by the operating system for extendable functionality at the runtime. So while you are running that certain task, to search for that particular library which is needed to run the task. So that's why you need ld library path. It basically searches for the library you need, gets the path name, and uses it to execute it at runtime. Now, the fifth question. Name a service that you should disable which acts both as web and FTP servers on a Linux server. So web in the sense HTTP or HTTPS, and FTP servers. So you have to stop a service which basically stops both of them. So there is a service like that. It's called finger service. So the finger service should be disabled on a Linux server because the remote user can get important information about the system by using this command. Basically, there is a Linux server, you are using it, you are the let's say the admin or the super user, and your system is also used by multiple users who are using it remotely from their own PCs. In that case, you can use the finger service command to get all the information about them. So basically, you can get their login name, their full name, and possibly other details as well. So you can get into their system and you can get possibly other details about the user. So this is why this should be disabled on a Linux server, because it acts as both a web and FTP servers. That basically means it also shows the web pages if you want to run. Also, it can get files, it can transfer files from other servers to your server or your server to other servers. So that's why it has to be stopped, and that service is called the finger service. And the main reason it has to be stopped is because it can get important information about the remote users from your PC. So that has to be stopped. Now, what does SAR provide? Where are the SAR logs stored? Now, SAR is basically a command. Now let's look what command it is. In Linux, the SAR command collects, reports, or saves system activity information, and it serves to log and evaluate a variety of information regarding system activity. So SAR is basically a command which records system activity, and with performance problems, SAR also permits retroactive analysis of load values for various subsystems. So basically, it checks out the system activity. Also, it checks out CPUs, memory, disks, interrupts, network interfaces. So it checks all of this. It basically has the value of all of this. And the SAR command is basically used for this. If CPU is near to 100%, the sampled workload is considered to be CPU bound. So let's say there is a load running on your server, and if the CPU goes to 100%, that basically means the workload you are running basically takes up a lot of CPU, not memory or other things, but it is CPU bound. So that's exactly what SAR does. Checks out system activity information and also all the other required information about CPUs, memory, disks, interrupts, network interfaces, and so on, like devices. And next question was, where are the SAR logs stored? So to check out all of this activity information, you'll have to go to the /var/log/sa/sadd file. So inside var/log/sa, there is a folder or a file called sadd, and you'll have to use that file to check out those logs. So all the log files will be stored over there. By default, the log files are stored over here, where the dd parameter indicates the current date. So you can see over here. So var log/sa. Inside this folder, you have sa and you'll have the current date over here. So this is what depicts the current log files. Okay guys, so this is what SAR provide, and this is where the SAR log files are stored. Next question is how to check memory stats and CPU stats as a Linux admin. So there is a command called free and this is a command called vmstat. So now we can display the physical and virtual memory statistics respectively. With the help of SAR command, we can see the CPU utilization and other stats. So SAR does not need to be run manually. It already runs in the background. You'll just have to run the vmstat or other commands and SAR logs will be fetched and you'll be given the information. Over here you can see they have also provided CPU information. They've also provided memory information. So they have provided system information, input output information. So now they've asked us, can we check memory and CPU stats? Yes, we can check. We can just use the vmstat command -a and it will give you the free memory. So if you use free memory, if you use the free command, it only shows the free memory. It does not show the CPU of the system. But if you want to check both at the same time, you can use vmstat and it will show all the details over here. And the Linux admin can use this. Next, how to reduce or shrink the size of the LVM partition. So now LVM is basically logical volume manager, where you can manage all the sizes of the disks. So now they've asked us how to reduce it. So now let's check out the steps. So here are the logical steps to do that. First, you unmount the file system using the unmount command or the umount command. So there won't be an N. You can use the umount command or the unmount command. Next is the resize to file system command. So now you use this resize to file system command to change the size of the logical volume partition. So there is only one disk with multiple logical partitions. For example, in your Windows system, you might have D drive and C drive, but they are not actually separate disks inside your PC or inside your CPU, but they are a single disk which are separated logically by the system. So like that, you can also separate in Linux. So to resize one of your logical volumes, you'll have to use the resize to fs command. So resize to fs /dev/mapper /myvg-mylv. So this is the logical volume name. So inside device you can find all the logical volume devices. So now they are changing it to 10 gigs, and then you'll have to use lv reduce command to reduce the volume to 10 gigs. So over here, lv reduce minus capital L or hyphen capital L, 10 gigs, 10G, and the same location. So this is to resize it, and this is to reduce the size of the volume. So this way we can reduce the size of the LVM partition and fix the size of the file system to 10 GB. So if you want to make it 30 GB, you'll just have to change the values over here. If you want to make it to 25 GB, again, only the values, and also the logical volume name will be different in your PC, in your Linux system. So you'll have to check that out and insert the correct address over here, otherwise it won't work. Coming to the 9th question. Below is a list of what are the different modes of network bonding in Linux? Below is the list of various modes you use in network bonding. So now network bonding is basically combining multiple network interfaces together. So check out what are network interfaces before looking at this question. Okay, so now there are multiple options. First one is balance minus RR. This is basically for round robin or 0. The round robin mode for fault tolerance and load balancing. We can use the round robin way, and the mode is 0 or balance minus RR. Next is the active backup mode for fault tolerance, which is set to number 1. And coming at number 2 or balance -XOR sets an XOR mode for fault tolerance and load balancing. Then fourth, broadcast or 3 sets a broadcast mode for fault tolerance. All transmissions are sent on all the slave interfaces. So all the slave interfaces, in the sense there will be a master network interface which is connected with multiple network interfaces, and all the transmissions will be sent to all of them. Then 8.2.3 AD or 4 So it basically sets an IEEE 802.380 dynamic link aggregation mode and creates aggregation groups that share the same speed and duplex settings, which basically means when you combine multiple network interfaces, all of those network interfaces will share the same speed and will share the same duplex settings. That basically means all the transmission, whatever happens through these network interfaces, will have the same speed, will not change. Next comes number 5, or balance TLB. So this is called transmit load balancing. It sets up transmit load balancing for fault tolerance and load balancing. And finally, balance ALB, which sets up active load balancing mode for fault tolerance and load balancing. So these are the 7 different modes which can be used in network bonding. So network bonding, as I told you, it basically is combining or joining together multiple network interfaces. So understand that if you do not know about this question, only then you can understand what is going on over here. Finally, the 10th basic question is how to check and verify the status of the bond interface. So bond interface basically means the same as network bonding. Once you bonded it, it's called bond interface. So now, using the following command, we can check which mode is enabled and what LAN cards are used in this bond. So cat /proc/net/bonding. So this is the normal path which you'll have to look in your Linux system to find out all the bonds available. So you can name the bond accordingly. Over here, there's a bond called 0. So in this example, we have a single bond interface. However, we can have multiple bond interfaces as well, bond 1, bond 2. So you can have multiple bond interfaces within the same location. So to check and verify if a bond interface is available in your Linux system, you'll have to go to this particular address, that is proc net bonding/bond0. If there is bond 0 or bond 1 or bond 2 available inside that, your bond interface basically is available and it is verified. Okay guys, next let's move on to the intermediate interview questions. So the first question is, how can you enhance the security of the password file in Linux? So there is a password file called /etc/password in your Linux file system, and so you'll have to they're asking you how to make this even more secure. It is in the test file named etc password that Linux usually keeps its user account details, including one-way encrypted passwords. However, this file can be accessed with the help of different tools, which might throw security issues. Basically, even though this file has one-way encryption, you can use certain tools and people can easily get the details out of this file if they get the access to the file. So to minimize the risk of that happening, we should make sure you use a shadow password format that saves the account details in a regular etc/password file as in the traditional method, but with the password stored as a single X character. That is, it is not the original password that is actually stored in this file. Meanwhile, a second file, so there are 2 files basically, it's a shadow file. This file replicates, people will think this has the password, but the second file, which is the shadow file, etc/shadow, will actually have the encrypted password along with the other relevant information, so such as account or password expiration date. Most importantly, the later file is readable only by the root account, and thus it minimizes the security risk. That basically means the first file, etc/password, can be read by any user on the system, but the etc/shadow file can be only read by the administrator or the root account. So basically nobody else can access it, and it minimizes the risk of your password going to another person's hand. And this is how shadow password format works. You have 2 files, etc password, etc shadow. etc password has a single character X as your password, but etc shadow has all the details and only the root account can access it. The 12th question is, what command can you use to make a tape archive file of /home directory, so /home directory, and send it to the /dev/tape device? So let's say there is a tape device attached to your Linux operating system and you want to send the home directory, you want to tar the file, or you want to tape of the archive file and send it to /dev/tape device. So what do you use? So you have to basically tar the file. So if you don't understand what tar is basically like zipping your file in a Windows operating system. So now you use a -xvf option is used to extract files from an archive. -cvf file is basically to tar it together. Xvf is to retar it or untar it. It basically removes the tar. Okay, now cvf/dev/tape/home. So what happens is, this is the destination and this is the directory which will be tarred together, and that file will be sent into this destination directory. So this is the command you use for that. So not just home directory, any directory or any file you want to tar and send it to a particular location or a particular device, this is the command you use. 13th question. Suppose your FTP server is hacked and the entire server needs to be restored. How would you restore the original kernel system files? So now the FTP server which you have is hacked and the entire server needs to be restored. So what can be done? We cannot restore the entire operating system from the tape backup device. Therefore, we should reinstall the core operating system. That is, you cannot directly reinstall the operating system just from the tape device which you have, just from the backup device which you have, but instead you'll have to reinstall the operating system, and once it is reinstalled, then you'll have to basically restore the system configuration, basically the users, the details of the system, everything should be restored, and also the user data and all the other files from the backup device then can be moved to the Linux system which you have just installed. So that's how it works. And yeah, so that's basically it. You cannot directly take all the details and put it into the system. First you'll have to reinstall the core operating system, and once it is installed, you'll have to take the configuration files and user data and all the other files into the system which you just installed. The 14th question. Why should you avoid telnet to administer a Linux system remotely? So telnet uses the most insecure method of communication. So basically that's the reason why you shouldn't use telnet, because it's pretty insecure. It basically sends data across the network in a text format that anybody can read. So if you get into the network, you can basically take this file and check out this. So check out the data within the file, because it's not encrypted, and in that case it's just plain text, and anybody who finds out the password which is being sent using just a simple networking tool. Now it includes the passing of the login credentials in plain text. Anyone running a sniffer on the network, that is, let's say you have an intra network, let's say it's a college network, in that case most of the time people don't care about using a more secure line of communication. They just go with telnet because it's pretty easy to set up. So in that case it sends out plain text, and if a college student, if anybody uses just a sniffer, they can get those files and they can basically start using whatever network the college is using. So make sure you don't use telnet. So you can see in a few seconds, by eavesdropping on a telnet login session, you can get the control of the device which is being which is sending that information. So now the 15th question. Name 4 configuration management tools used in Unix like operating systems. So there are mainly 4: Chef, Ansible, Puppet, and CF Engine. So I know about Chef, Puppet, and a little bit about Ansible. So now Chef and Puppet basically are so all of these are configuration management tools. They do the same tasks. So the common task here is they are like a master to multiple clients or multiple Linux servers. Whenever you want to upgrade or whenever you want to run a configuration file in hundreds of servers, you can send it to Chef or Puppet or Ansible or CF Engine, and they'll make sure it runs on all the servers which you have. You don't need to open each and every server and run the configuration file. You should set up Chef, which basically manages all the servers for you. So I'm just taking Chef as an example. So these are the 4 configuration management tools. Coming to the 16th question. What is the difference between CRON and ANACRON? So now, if you know what is CRON and ANACRON, obviously you'll already know the answer. So now let me explain what exactly is CRON and ANACRON. So minimum granularity with CRON is in minutes, when it is in days with ANACRON. So first let me tell you what is CRON and ANACRON. So basically CRON or ANACRON both are used to schedule tasks in the future. So you can schedule a particular task. Let's say you want to take a backup of a file. You can schedule the task by creating a cron tab script file, and that will automatically execute at that particular time when you are mentioned, and it will basically take a backup of that file. So this is the basic task of CRON and ANACRON. So now you can use CRON to run in minutes. That basically means you can set 2 minutes. You can set a CRON tab for minutes, but using ANACRON you can only set it in days. That is, it can only repeat running, or it can only work with days, but CRON can work in minutes. A CRON job can be scheduled by any normal user. So even I can do, even you can do if you're using a Linux server, and I'm just a normal user, and there is also a super user, there is also an administrator, so any of them can create a CRON job. But ANACRON can only be created by a super user or the administrator. CRON expects the system to be up and running, while ANACRON doesn't expect this all the time. In case of ANACRON, if a job is scheduled and the system is down at this time, it will still execute the job as soon as the system is up and running. So in the case of CRON, if the system is down, basically it won't have any idea of what to do. So basically the time passes, and once the time passes, the CRON job will not run. But the ANACRON job, even though the system was down at the time, if the time has gone beyond the set time, it will still run the job and execute it. So now, CRON is ideal for servers. ANACRON is ideal for both desktops and laptops. So CRON ideal for servers in the sense if you're running a task for your application which is hosted in a cloud server, in that case go with CRON. If you're doing it for a local desktop or a laptop, go with ANACRON. CRON should be used when we want a job to be executed at a particular hour and minute, and ANACRON should be used when the job can be executed at any time. It basically means if the time passes, ANACRON will still run and execute it, but CRON won't do. If the time passes, it won't do. It will only do at the exact minute or the exact hour you have mentioned. So that's the only difference between CRON and ANACRON in this case. But so CRON is suited for servers, ANACRON is suited for desktops and laptops. I think you got the difference between CRON and ANACRON. They both are used to schedule tasks, and CRON can be only used by all kinds of users. ANACRON can only be used by a super user or an admin. So now, which command is used to check the number of files, disk space, and each user's defined quota? So the rep quota command is used to check of a user's defined quota along with the disk space and the number of files used. So over here you can see the command being used, rec quota minus a. So this report is for this particular device. So block grace time 7 days. So you can see all of the tasks which are done, all of the users who are using it, and how much data they have used. Over here you can see the used data. So you basically set up file limits. You can basically set up all kinds of limits over here. And to check the each user's quota, each user's limit, you should use the rep quota minus a command to see all of that. This command gives a summary of the user's quota, that is how much space and files are left for the particular user. Each user has a defined quota in Linux. This is done mainly for security as it restricts files from unwanted access. The quota can be given to a single user or to a group of users. So I think you got the answer for this question. So they asked what is the command to check the number of files or disk space which is basically allotted for a particular user. So to check out that, you'll have to use rep quota minus a or space hyphen a. The next question is, what is the name and path of the main system log? By default, the main system log is available in /var/log/messages. This file contains all messages and scripts written by the user. By default, all scripts are saved in this file. This is the standard system log file, which contains messages from all the system software as well, non-kernel boot issues, and messages that go to dmessage. The dmessage file is a system file that is written upon the system boot. So the name of the main system log is messages, and the path is /var/log/messages. So the user scripts, the scripts or messages from system software, non-kernel boot issues, or any kinds of messages will be sent to this particular location in default. The 19th question, can we convert a Linux computer into a router in order to enable multiple machines to work on the same internet connection? If yes, how? we can convert a Linux PC into a router so that it can act as an IP gateway for a network. This process of turning a Linux machine to a router is referred to IP masquerade. So you'll have to do Linux IP masquerading to enable this and the other internal computers that are linked to the Linux system to get connected to the internet. In Linux, we can perform IP masquerading by following the below steps. So now, in the next slide, I have all the steps. So to understand this, basically, there is a router which has basically limited connections. So let's say 20 connections, and there are 20 more systems. So now we want to give internet connection to those servers or to those computers. In that case, you can basically change the Linux computer into a router. So to do that, you'll have to do IP masquerading, and to do that, these are the steps. So first, you have to make sure that the Linux PC is having an internet connection. So whichever PC you're going to change it into a router should have internet connection, and also it should have a LAN connection which connects across to all of the other computers. In fact, a Linux PC will be having a PPP connection and an Ethernet card. So obviously an Ethernet card will be connected to it. So now, as the default gateway for TCP IP networking, all the other systems on our LAN use the Linux machine. So apart from the default gateway, every other system uses the Linux machine. Hence, we have to use the same DNS addresses provided by the internet service provider on our all systems. So that basically means the gateway, the main IP address to use the internet. So that particular DNS addresses should be provided. You have to use the exact same DNS address in all of the computers, even though they are connected to this particular Linux system. So now, for enabling IP forwarding, we'll have to use the following command. So first, you'll have to echo 1 greater than. Greater than, since it basically writes that information into this particular variable. Okay. So now /proc/sys/net/IPv4, and inside that IP_forward. So we are basically forwarding the IP addresses to all the other computers. So for checking whether we have IP forwarding enabled already, we can use the following. So basically, this is to enable IP forwarding, but if it's not working, that basically means IP forwarding is already enabled. So to check that, use this command systemctl net.ipv4.ip_forward. So when you check this, if it shows 0, that basically means it's not enabled. So, or you can just use cat for this particular command. So basically what we are doing is we are basically toggling it from 0 to 1. So once we toggle it from 0 to 1, you start forwarding the IP address to other computers. So to check, we have these 2 steps. And once all of that is done, finally we will run the IP tables for setting up those rules that enable IP masquerading. So inside IP tables, you can set up what are the IP addresses that can be used by the Linux computer and the other client computers. So I think this is it. You just have to toggle IP forwarding. Once you toggle IP forwarding, IP tables is like a firewall in which you set up like whether those Linux systems can use these domains from the internet. So that's it. Once you set it up, all the Linux systems which are connected to this particular computer, which is turned into a router right now, will get internet access. The 20th question and the last question in the intermediate questions. So in Linux, how would you change the window manager? The /.xiниtrc file or Xinitrc file lets us change the window manager that we will use while logging into the Xwindow session. So the dot in the file, so it basically tells a particular file is a hidden file. It also means that this file will not be present when we carry out a normal directory listing. And in order to set up a window manager, you'll have to execute the following command. So to change, before changing it, you'll have to set up a window manager. To set up a window manager, you'll have to use exec window manager command. Once we are done with this part, the next step is to save the file. This way, a new window manager opens up every time we run a start X and it becomes the default. Now let's check out the commands used for starting some very common desktop environments and Windows managers. So if you have used Linux systems, you would know about Window Maker or GNOME or Blackbox because these are popular window managers. Mostly I use GNOME. So basically, to start off these window managers, you'll have to use these commands. So for GNOME, you'll have to use gnome-session, and for black box, it's black box in lowercase, start kde, wmaker, fvwm, icewm. So basically, to run all these window managers, you'll have to just use it. That's it. So you don't have to do anything else. You'll have to install these window managers already into your system and then just run these commands, and it would change the window manager for you. Okay, so we've seen the intermediate questions as well. Now let's look into the advanced interview questions. Start off with it. How are shadow passwords given in Linux? So we already know about that. We already know the basics. There are two files, password and shadow. Password has X, shadow has the details. So now in Linux, pwconv command is used for providing the shadow passwords. So shadow passwords are given for better system security. We already established that. This command creates the shadow and changes all passwords to X in the password file. So this is the command which does that particular action. So we saw that the password file will contain the passwords as X, and shadow file actually contains the actual information. So that is done by the pwconv command. First, the entries in the shadowed file which don't exist in the main file are removed. So the first line basically means, so there will be multiple entries in the shadowed file. If those particular entries do not exist in the main file, they'll get removed in the shadowed file because there is no use for them. Then the shadowed entries that don't have X as the password in the main file are updated. So in the main file, all of those passwords are updated to X, and also they are updated in the shadowed file. Any missing shadowed entries are also added. So if there are any missing shadowed entries in the shadow file, but it is available in the password file, that will be added to the shadow file. Finally, passwords in the main file are replaced with X. These programs can be used for initial conversion as well to update the shadow file if the main file is edited by hand. Okay, so this is how you do it. It's pretty simple. It's just the command pwconv you use, but the steps are basically these. If you use the command, it will do all the things for you. Basically, you remove all the entries in the main file if they do not exist in shadowed file, and if they don't have the if they are not changed to X, it will be updated in the main file. And if there are any shadow entries which are missing in the shadow file which are available in the main file, they'll get updated and also added. That's it. Coming to the next question, what daemon is used for scheduling commands? So we already established what cron is. So cron exactly is used over here. It is called cron tab over here. Daemon which you use for scheduling commands is cron tab command. So cron tab command is used to scheduling commands to run at a later time. So cron tab is a command which is basically used to set up commands to run later. Over here you can see cron tab -user, username, and file. So inside this file you'll have all the commands which you need to run at that particular time. And over here -l displays the current cron tab entries. So this is the way you write. This is the normal syntax. So inside this file you have all the commands which will run once the time arrives. So this -r removes the current cron tab. So let's say you have created a cron tab and you want to remove it. In that case you'll have to use -r, and -e basically it opens the visual editor, and once it opens the visual editor you will be able to edit the things inside of it. When a user exits from the editor, the modified cron tab will be installed automatically. Each user can have their own cron tab, and though these are files in /var, they are not intended to be edited directly. So basically they are files, but you shouldn't edit them directly. You should use the -e command to edit them using the visual editor provided by the cron tab itself. So the daemon used for scheduling commands is cron tab. Coming to the 23rd question. So what shell does a Linux administrator assign to a POP3 Mail-only account? Okay, so now a Linux administrator assigns a POP3 Mail-only account to a bin/false shell. So it basically means it's a fake shell. Okay, so now however, assigning a bash shell to a POP3 Mail-only account gives the user the login access, which is usually avoided. So the bin/no-login shell can also be added. So the POP3 Mail-only account is added to two different shells, false and no login. This shell is provided to the user when we don't want to give shell access to the user. It is mainly meant for the security of the shells. So you give this particular shell usage because you don't want the user to get into your shell. Now POP3 is basically used for downloading mail-to-mail programs. So you basically download the mails online and you can read it anytime offline. So now this account is assigned to /bin false shell or /bin no login shell. Both shells are the same as they do the same work of rejecting the user to the shell. So basically, if somebody is trying to illegally download emails, in that case, if you have provided them the access to false or no login, so basically they won't be able to enter the shell itself. They'll be rejected before logging in. The main difference between these two shells, between false and no login shell, is that the false shell basically shows the incorrect code and any usual coding when a user logs into it, whereas the no login shell simply tells us that no such account is available. Therefore, the no login shell is used often in Linux. So basically the difference is the false account or the false shell shows incorrect coding, which does not allow the user to get into the shell. But the no login shell basically tells the user that there is no shell like this available. You cannot log into this. That's it. So this is the Linux shell, which is basically assigned to a POP3 mail-only account. False or no login shells. Coming to the 24th question, if a volume group named VG0 already exists and we need to extend this volume group up to 4 GB, how do you do it? So there is a volume called VG0, you'll have to extend it to 4 GB. So to do this, you need a command. So first you need to create a physical volume /dev/sda7 or a name which you like, sda7 or whichever name you want to provide, of size 4 GB. So once you created a physical volume of size 4 GB, then you will run the command vg-extend the name of the volume group, which in this case is VG0. And once that is provided, you'll have to provide the device name which you have created, which is the size of 4 GB. So now the already existing volume group will add this 4 GB to that group, and 4 GB will now be added, and this is how you do it. Coming to the 25th question, is there any relation between the modprobe.configuration file and network devices? Yes, this file assigns a kernel module to each network device. So any network device which is connected, so the modprobe.configuration file basically assigns a kernel module to each of these network devices, so they can be running their own tasks over the kernel modules. Over here, alias Ethernet 0 B44. Here B44 is the kernel module for network device Ethernet 0. We can confirm whether this module B44 is present or not by following command. So lsmod/grep b44. So the b44 kernel module exists, and it exists because of the modprobe.configuration file. Modprobe.configuration file is the one which assigns a kernel module to the network devices. So one of the network device is an Ethernet device, basically connecting the internet, right? So it's an Ethernet 0 device, and basically it has a kernel module b44 assigned by the modprobe.configuration file. Coming to the 26th question, it's simply what is yum? So yum is a package manager. So it stands for Yellow Dog Updater. So right now it's Yellow Dog Updater modified. So it's called yum because it's based on the Yellow Dog Updater, but it is a little way it's modified. That's it. Like how vi changed to vim, the text editor, like that u or yu changed to yum. So Yellow Dog is a version of Linux for the Power architecture hardware and is RPM based, just like Red Hat Enterprise and Fedora. So it's basically a version of Linux which lets you gather files or gather packages from multiple locations. So now yup, that is Yellow Dog Updater, and later yum. Right now we use yum, which is Yellow Dog Updater modified, were written by the Linux community as the way to maintain an RPM based system. So RPM is an open source package manager from where you can download all the open source libraries and packages which you need for your Linux system. So to download that, you'll have to use the yellow dog updater or the yellow dog updater modified, which is yum. That's it. It's written by the Linux community to keep it open source and download all the open source libraries and files and applications directly from the RPM package manager. Coming to the 27th question, what's the role of kudzu? Kudzu is used to detect new hardware. So the Red Hat Linux runs a hardware discoverer called kudzu. So now when attempting to identify a serial port, kudzu resets the serial port. This stops the serial console. Kudzu is configured from the following file. So etc sysconfig/kudzu. Kudzu can be prevented from resetting hardware by setting the configuration parameter save to yes. So basically it tries to identify new software and it tries to reset it, but to stop it from resetting, we'll have to just set the parameter save to yes, and then it just identifies the incoming hardware and it won't change anything, it won't configure anything. That's it. The 28th question is the difference between ext2 and ext3 file systems. So now ext3 file system is an enhanced version of ext2 file system. So ext2 is the older version. The most important difference is that ext2 and ext3 is that ext3 supports journaling. So that basically means ext2 doesn't. After an unexpected power failure or system crash, also called an unclean system shutdown, each ext file system must be checked for consistency by the E2FSC program. This is a time-consuming process, and during this time, any data on the volumes is unreachable. So basically, if there is a power failure, or if there is a system crash which causes the servers to go down, if you're using an ext2 file system, in that case, you'll have to check each and every ext2 file system which is connected to the server by the E2FSCK program. So that basically means in that case, you'll have to run the E2FSCK program in each and every ext2 file system, and that is time consuming. So now ext3 has journaling. So that basically means by providing ext3 file system means that this sort of file system check is no longer needed after an unclean system shutdown. It basically keeps all the files safe. You don't need to run E2FSCK each and every time after an unclean shutdown, that is a shutdown when the system goes down suddenly without saving anything or doing anything. So ext3 does not get affected in this case. Now finally, the 29th question, explain the /proc file system. So the /proc file system is a virtual file system that provides detailed information about the Linux kernel, hardware, and processes running within it. The files under this proc directory are named virtual files. Since /proc contains virtual files, it is called a virtual file system. So basically, all the virtual files are available in the proc directory. Therefore, it is called a virtual file system. These virtual files have unique qualities. Most of them are listed as 0 bytes in size. Virtual files such as interrupts, memory info, mounts, and partitions provide an up-to-the-moment glimpse of the system's hardware. So basically, it's a really important directory. It is called the virtual file system. So basically, if there are any interrupts, if there about the memory info, that is the free memory, available memory, the disks which are mounted, the partitions which are available in the PC. So all of that information is in the virtual files which are stored in the virtual file system, which are basically noted as 0 bytes because they are very, very small or very short files. So these provide an up-to-the-moment glimpse of the system's hardware. That basically means you can check out real-time information of the system's hardware using the proc file system or the virtual file system. So you can see the virtual file system is over here, and all the processes run, and all the processes which are running will go through it, and the virtual file system will know all of the processes which are running at that particular time. And the final question, how do you create an ext4 file system? So right now, ext4 is the most commonly used file system, not ext3, not ext2. So we can create an ext4 file system with this command. So mke to fs, so it is basically make file system. So you can use mke to fs. -t basically denotes which file system you want to create. In this case, it is ext4. and /dev and the /device name or the folder name in which you'll have to create the ext4 file system. So this is the command which you'll have to use, which is make to file system -t, your file system name, which is ext4, and then the device name, and that's it. You have created an ext4 file system successfully. Okay guys, I think we've completed all the 30 questions. Thank you.